Hello, teachers and students. I'm Huangbin Hao from ECAS China University of Science and Technology. The title of my paper today is Social Science Aware Generative Adversarial Network for Pedestrian Trajectory Prediction. First of all, let me briefly introduce the background. With the frequent occurrence of public safety accidents, the development of intelligence security, and the introduction of green translation, pedestrian trajectory predictor plays a very important role in this aspect, and is crucial across a wide range of applications like self-driving cars and social robots. It can help the manager predict the potential trajectory of the target pedestrian, and it can help intelligent robots with social need to better handle the pedestrian interaction, and it also help self-driving cars accurately predict the potential future trajectory of roadside pedestrians. Then there are many classic papers before this, such as social esteem in 1916, which took advantage of the directed characteristics which took advantage of the characteristics of the long short-term memory in processing sequence. And the social gain in 2018 introduced the novel generative adversarial network to pedestrian trajectory to predict the future trajectory dispute of pedestrian. In 2019, Sophia added the attention machine. He used physical attention and social attention to better simulate pedestrians going forward. However, such prediction is challenging because broad behavior is inherently determined by various factors such as obstacles, stationary guard groups, and destinations, which were difficult to efficiently represent, and the pedestrians tend to be greatly affected by the person in front of them more than those behind them. So the contribution of the paper was summarized as follows. Thin energy map method is proposed, which can jointly model thin factors such as obstacles, destinations, and stationary crowd groups that affect the growth of pedestrians. And the second one, a social self-attention pooling module based on final view is proposed to handle trajectory interaction between pedestrians, which can better simulate the forward intent of pedestrians in real sense. Experiment result on 5 public data set prove the effectiveness of the method and extensive application. This paper will propose a novel framework of social science of a generic adversarial network means SSA again to sequentially predict the coordinate displacement between two ramps for each pedestrian, which include 3 modules: scene module, social mode, and game mode. The scene module can capture information such as obstacles, stationary groups, and exit in space. Social model will focus on the interaction between pedestrians, including the pedestrian attention weight and the scope of vision. Field of vision. The game module can help deal with the multimodally of pedestrian trajectory and select the one close to the ground truth. Scene module has three major components: scene obstacles, stationary groups, and destination. We firstly establish a general energy map module and then establish three sub-energy map in turn. Through sampling, use maximum likelihood estimation and gradient descent to obtain the weight of each parameter. And finally, substitute the energy map for energy map formula to obtain the result. The social module first is some encoder process. Then energy map information in the neighborhood around the target pedestrian represents the social activity value for the pedestrian's next step. Later, the code encoded by multilayer exception together with the position information of pedestrian. As a common knowledge, pedestrians' future direction were always influenced by people in front. So we combine the self-attention machine and the field of view information to obtain an updated embeddings. Game module will connect the noise vector Z with the sum context vector to obtain the distribution of trajectories, and the discriminator will sample from real and predict trajectory to identify. Parallels variety laws like social gain can find the one closest to the ground truth in the multimodal trajectory. We use average displacement error and final displacement error as evaluation indicators, evaluation metrics. These are our experimental results on the ETH and UCY dataset. In general, our method is significantly better than the previous benchmark method. SISTM is slightly better than our method on the ETH dataset due to its set-find processing. Then this is our visualization result. It can be seen that trajectory distribution were deviate significantly in the context of no constraint or only one constraint. When both the scene and the social interaction are considered, the trajectory distribution is more in line with the ground truth. This is our application experiment. Since the CSD dataset has a list of entries and exits and stationary groups, the result of application experiments on this dataset shows that our method can better understand these scene factors. A and B, image A and B, respectively show the comparison between our method and the social gain in a stationary group scene and the scene with extras and exits. Visualization, the visualization results prove the effectiveness of a method. Okay, the above is the content of our paper. Thank you for your attention. That's all.